Okay, welcome to Business Analytics 121. We're going to start off in Chapter 8 with some examples, and you should have the Excel file to follow along with. So the first example they give us is talking about economic value and determining the economic value of a customer per year. So remember, you remember the Netflix example, lots of businesses are interested in which customers are valuable and which are profitable and which ones aren't profitable and how much profit. Remember the Netflix example where we talked about the infrequent users. That was kind of the sweet spot. The guy that had the Netflix subscription but only watched a couple movies a year was very, very profitable to Netflix, as opposed to the customer that was a frequent user of the service. So anyways, in this example, and they've kept it rather simplistic, they use R for revenues per purchase, F for purchases frequency and number of years, so that's how often this customer purchased, M stood for the gross profit, and D stood for the defection rate. Okay, the percent of the customers that defected, that changed, that left us for another supplier. So they came up with a function of loyalty per customer per year, which would be the revenue per purchase times the frequency of purchases times the gross margin percentage divided by that defection rate. So what we've done down here is we've listed our assumptions, and we've said assume to keep the model relatively flexible. Revenue per purchase they said was 35,000. If we assume purchases per year, now here I'm using an example of an auto dealership. I'm not sure they gave us exactly numbers for this. They didn't give us any specific numbers, so I'm using the numbers. I'm assuming a car, an auto purchase, 35,000 for the car. They purchase a car about once every 5 years, so that would be 0.2 in any given year. Gross margin on a car I assumed to be 15%. And then I did a couple scenarios. What if the defection rate was that car customer never came back to us? Well, I just put the equation in here, and here you can see the equation. It's just a model of this. It would be my A10 times my B10 times my C10. And notice I've put all of this in parentheses because I wanted to do that first and then divide by the defection rate. So when we do that, we get the annual value of each customer's $2,100. Now, I gave you another example here. If we could cut that defection rate in half, from 50% to 25%, look what happens to the value of that customer. It doubles. I put a little chart here that just did this cell divided by this, to see the percent change. And the thing I like about the model is it's flexible. I can put in 40%, see what happens. It improves by 20% our earnings. I can put 30% in here. That's the power of some of the Excel when you make the model, set it up with your assumptions, your results, and this gives you the value of a customer. Now, some businesses might want to play around with this function or have slightly different functions, but it gives you a lot of power here in a model that says, what's the economic value of a customer? Let's look at example 8.2. It's a profit model. So now we're going to determine a profit model when demand is uncertain. Okay? So our variables P is for profit, R is for revenue, T is for total cost, P is for unit price, C is for unit cost, F is for fixed cost, S is for quantity sold, Q is for quantity produced. Now, remember when we took BAS 120, most of our models assumed that the quantity sold and the quantity produced were always the same, and we never had any inventory left over. And we talked about in that course, we said, well, that's a rather simplistic assumption we're making, that just because we produce it, we'll sell it. Now we're getting into this game or this modeling to say, well, wait a minute. If we produce it, we might sell it. We might not sell it. We might have what's called some lost opportunity sales. Let's say we produced 10, but we could have sold 20. The demand was for 20. Well, we can't say we sold 20. We only produced 10. So D is the quantity demanded. So our total cost is from BAS 120. It's our fixed costs plus our variable costs. Well, our variable costs are our unit costs times the quantity we produced. Fixed costs plus variable costs. Our variable costs are our cost per unit times how many quantity we produced. Our revenue is going to be the quantity sold, right? Because now again we're not assuming that just because we produced it, it's sold. It's the quantity sold times the unit price. Now, the quantity sold is going to be whichever is less, the quantity demanded by customers or the quantity produced. So we think about that. Hopefully that makes sense to you. If the quantity we sell is whichever is smaller, how much we produced or how much was demanded. If demand is less than what the quantity we produced, then we'll have leftover inventory, right? Because we'll only sell the quantity demanded. If demand is very, very high and we only produced a few, well, we can't sell something we didn't produce. So the S in this function, or the quantity sold, is the minimum between the demand and the quantity produced. That leads us to the revenue function, which is going to be our unit price times our S, or our quantity sold, which we just said was the minimum of D and Q. So our profit, if you remember, profit is revenue minus cost. So all we've done here is made our profit function to be the revenue, which we stole from right here, minus the cost, which we stole from right here. Okay, now let's model this. And they told us demand was a linear demand function, B minus A times P. So here are some assumptions. So I put in a couple additions here just to, I said, well, what's our starting point and what are our price increments so we can have different, so we can see some tables. Here's what our assumed B was for our demand function, and there's our assumed A, or our slope of our demand function. And of course, we put these up front here so you can change any of these assumptions. Here are the assumptions, and then of course here I just took the unit price to equal that, whatever I said the starting point was, and then this is the starting point, the point up here above, plus whatever increment we're increasing it by. So those functions should make some sense to you, right? So that allows us to fill that down so we can see it several different price increments, and it gives our spreadsheet lots of flexibility. Of course, this is an assumption. This is an assumption. We also make assumptions in this model, as you can see up here, on our unit costs, on our fixed costs, and the number of units produced. Now, our results are right here. It's going to be, our demand is going to be our quantity demanded. Well, here's our demand function right here. So our demand is whatever our B is minus A times P. Well, our A is 200 and our P is our price, which we find right over here, which we've made various assumptions on. So that's our demand. And as you can see, as our price goes up, not surprisingly, our quantity demanded is going to go down. Our quantity sold, as we set up here, is going to be the minimum of whatever our demand is versus whatever we produced. So notice right here, the quantity produced is smaller, so that's the number we did. Here again, the quantity produced is less. Then when demand becomes the lower of these two numbers, notice it's the demand that goes in here, because we've put a function in here that says the minimum of quantity produced and quantity demanded is what we're going to sell. Our total cost function, not surprisingly, is our fixed cost plus our variable costs. Our revenue is going to be our quantity sold times our unit price. Not surprisingly here in this example, since our unit price is 0, we're going to have 0 revenue. And our profit is just a function of our revenue column minus our cost column. Then we filled these down, and there's some very interesting things you can see. Notice what's happening to our profits. Our profits are negative, then they become positive, then they peak, and then they begin to decline. So there's some, we could expand this and use our solver. Remember, we've used solver before, where we go to data, solver, and we could say, you know what, I want you to maximize our profit by changing our price. And we said solve, and it said okay, and we learned that $23.75 is the optimal price for us to charge to maximize our earnings. So here's a very powerful profit model. You could use it for several scenarios. We've set it up. You've got the Excel spreadsheet. Go ahead, play around, adjust it as need fit. We've done it under several different pricing scenarios. We know our profits. We could graph it if we wanted to. We could come down here and we could say, you know, for these prices, hit our control function. What are our profits? And we could say insert chart that shows us this stuff. And there you see, at different pricing levels, our profits increase and then they start to decrease. And as we said, at about $23.75, right about here, that's where we maximize our profits. Oh, hope this helped. If there's any questions, send me an email. Have a great day.